Okay, so here we go. Welcome everybody. I'm Dan from the IBOTS. I've got Forrest with me here. He's my co-helper, guy behind the screen. And we're going to do an overview of the control system today. We're going to talk specifically about the hardware and any issues we've had in the past, any secrets and tips and tricks and things we've learned. And then I'm going to actually turn it over to Jacob for a second because we have some guests. So you're up.
Hi, I'm Jacob Janssens, one of the lead mentors for 3623 The Terabots. We're from Massachusetts, and 2017 co-champions WPI regional or WPI district event with 2370.
The crazy pick from left field.
Yeah, the pick that got Chief Delphi going. Wait, was that actually the second pick?
That can't be right.
Did Blue Line screw up?
All right, so we're going to talk about the control system today. It consists of all the hardware and the software used by the robot to read the environment, make decisions, and then act on those decisions. So basically, if you have any questions, again, just shout them out, and here we go. So anything in green is something the IBOTS specifically have had experience with. So we have a slide deck that we're going to share and email to you guys later on. So if you see the green, that's something very specific to what we've done, and keep an eye out for that because that's kind of our important special magic that we use. If you go online, I'm sure you guys already know this, you can find the electrical schematic. One I found from 3161 is probably the nicest one, the clearest, cleanest. It's got the wire gauges and everything, but it's readily available, and we're going to walk our way through each of these different components pretty quickly and then ask questions and chat. So the first thing we want to talk about is batteries. I'm going to start at the battery end of things. So do you guys have a battery beak, Jacob?
Yes, we do.
Yep. So for anybody who hasn't seen it, you want to zoom in? Ours has seen better days, but the battery beak that we've got, basically it will test the battery. It puts 18 amps across the battery.
Plug it into a battery.
And that's why I've got one right here. And what it'll do is it'll tell you the internal resistance of the battery, and it will tell you the approximate charge and whether it thinks it's good or bad or whatever. So you just press the button and off it goes and does the thing. Now the only bad thing is, I don't know if I can get it close enough to see. So this one says fair, and it's 130% charge. So the only bad thing is this thing only puts 18 amps across the terminals, which if you've ever done some calculations or seen the logs from some of your robots, you might find that you're doing 150, 120 amps under heavy load. And so
in a bit of pushing match, you'll peak easy at like 160, almost 200.
So, I mean, 18 amps is okay, but we have a question, is that significant? Is that sufficient to be able to actually tell the quality of the battery? And so, I'm sure you guys do, we've collected a random assortment of different manufacturers and models. And so as long as they're 18 amp hour and they're sealed lead acid, you're allowed to use them. On our slide deck, there is a list of first legal ones, but they're pretty open as long as it's the same shape, model, and size. So we talk about what makes the best battery. That's a pretty complicated question. I know that I've talked to the grasshoppers, and the only thing they use is internal resistance. So that's their metric for a good battery. But when you think about it, the manufacturers have different processes and quality controls. The plates are designed differently. They've got different chemical properties. You can't just judge a battery based on, the size or the shape. So the other things you got to look out for, especially if you've been doing this for a while like you guys, how many cycles has it been through? How deep were those cycles? Did we run it dead and then fully charged it? Every year, a battery gets bumped, dropped. There's physical damage. The ambient temperature, we're up in the Northeast. They go through cycles of hot and cold. Another thing to watch for, and on this one, we actually put clear terminals so you can see them a little better. Are you getting a good connection there? Are they loose at all? Can they move? So the quality of your terminals and gauges, and then the wire thickness. I know that we run 6, and that
we run 4.
Do we run? I don't know.
The new ones are all 4.
The new ones are all. We used to run just 6, so that's a 6. You can actually. I don't know if you can tell the difference in.
I believe we're running
the wire
6.
there.
I believe we're running 6.
That's a 4 versus a 6. So we've upgraded, and I know that the grasshoppers have started running 4 or 2. They're like crazy with the thickness of the battery they run. So the question we've had for a long time is, how do you know what's a good battery and what's not a good battery? And there's actually a team. I want to bring up that slideshow. There's a So which battery should we use? 2619, the Charge made a white paper a couple of years ago, and they went through a bunch of batteries, and they built their own custom tester, and they declared that the Duracell Ultras were the best, the D12 18N8s, which we get down in Albany, supposedly had the best performance. And we're talking 10, 15%. It's not a trivial amount. But they built a custom battery tester that would load 100 amps across it, 150 amps, and actually measure the volts and current and see how it performed. And that's something over here that we've been working on for a little while. We're kind of building our own custom battery tester here. We've got a little touch screen, and I've got a power board underneath and some speed controllers. And I'm building the load cells right now, but we're building a battery tester that should be able to give us that kind of insight to which battery is good and which battery is bad. Because you know what it's like. You're going out on the field and you don't really know what's your good battery, what's your bad battery. So that's something we're looking at. But for the moment, we've been buying the Duracells, and we've had good luck with them. I don't know. Do you guys have a battery preference that you love right now?
I mean, we've mostly been sticking to what we get out of Andy Mark in the kit. So, and those haven't been great in recent years. But then again, we've been playing more defense than ever.
I think the 2020s, we think we heard too many complaints. I know the 2019s, I know the Grasshoppers got a series of bad ones. That was a bad year.
Yeah, and we have a bunch of older batteries. Like I think we still have some in service from 2014.
And that's a good question. I mean, if you put 20 cycles on one battery, does that make that battery bad? I mean, could you have a battery with 100 cycles and still be in better shape than a brand new one? I don't know.
It's definitely possible depending on how well you maintain it. Like leaving it on a charger forever, leaving it not charged, like depleting it and not charging it immediately, and storing it like that is very bad for the health of the battery.
Yep, leaving it in your robot after you come back from a competition after running that last match.
And then not touching it for 2 weeks, yeah.
Yep. So that's just good thing. So one other thing to keep in mind, and I don't know, I haven't seen a lot of teams do this. Why don't you give me the close-up view? The other batteries you can use, which we started doing, are these battery packs, these USB battery packs. And you're allowed to use them as long as they don't put out more than 2.5 amps per channel, and they're not bigger than 20 amp hours. And I know a lot of teams say, well, that's not very much. Why would you bother? But we've sat on the field for 15, 20 minutes when they're goofing around or a field fault. And if our LEDs are drawing 5, 10 amps sometimes, 10 amps over 10, 15 minutes is actually a pretty significant battery draw. So that's something that we've started doing. If we have the weight, we add a second battery pack. It's basically free energy. So why not use that? So these battery packs, we just plug the LEDs into the USB ports and run them off the RoboRio. So that's something we've been doing just to try to save a little bit of energy. At the end of the match, if you're short on a climb, you wouldn't want it to be because of that 10% you spent lighting up the field beforehand.
Yeah, that's definitely a valid point, especially for, decorative stuff that isn't necessarily integral to robot function.
Yeah. Okay, so I'm going to go to the zoom in again. So the next step along, you've got the battery, and then right off the battery is your main breaker. This is the main breaker that turns your robot on and off. Every one of you should be able to find it on your robot. It's usually well marked, or it should be well marked for inspection. Some of the things we've seen in the past, and I'd be curious on your input, is we have seen them damaged. So we've seen teams mount them in places that weren't protected, and they had gotten
talking about us because we did it.
Did you guys do that?
Yeah, 2017, we broke 3 main breakers that year.
Yep, and I've seen it on other teams too. So one thing to keep in mind in your design is when you mount it, try to hide it a little bit, though you can't really hide it too much because they want it out in the open. But these are not really manufactured to be switches. They're not meant to be turned on and off a bunch of times. Their lifetime cycles is not very high. So we're not really, just like the batteries, we're not really using them as intended. So this main breaker, they do fail anyway. And so we generally put the older breakers that have been used on demo bots, and we use the new one just about every year just because we have seen, even if it's in good physical shape, you can do that 100 or 150 times and they do start to wear out and they don't. Now, we have never had one break. Have you guys ever had one pop in a match?
We have never popped the main breaker during a match.
I've heard about it, but I've never seen it.
Yeah, I could definitely see it on some really high load drivetrains absolutely happening, but I've never seen it personally. I've seen, game pieces get dropped on the red button and turning off robots before, though.
Yes, that's. And these are 120 amp breakers, so students should be aware that just because it says 120 amps, it doesn't mean that as soon as you hit 120 amps, it's going to pop. If you sustain more than 120 amps to the point where the internals of this heat up and the two pieces of metal spring open, that's what's going to pop your breaker. So, you know, if you run 180 amps for 3 seconds, it's probably going to be fine. If you start pulling 150 amps for 15, 20, 30 seconds in a row continuous, you might just pop that breaker. So it's something to keep in mind. You have a little bit of flexibility when the time comes if you need to really power through something. But I've seen more problems with these physically breaking than actually mechanically breaking. The other thing to keep in mind is always use this nut that has the star washer attached. That is something that we have seen the wires come loose. So if you don't tighten that down with a good star nut, you do risk the run. You run the risk of vibrating free and then having problems, and that's a match ender right there if your wire comes loose.
Those are not quarter 20.
Yes. So
we found that one
valuable
out the hard way.
lesson. These are quarter 28. These are one of the only things on an FRC robot that is fine thread.
Well, 1032 is fine thread technically.
Well, yeah, that's a good point, but. Yeah, this is not a quarter 20 stud. This isn't the same quarter 20 nut you put everywhere else in the robot. This is a very specific nut. Helps that it's gold. So that's just something to keep in mind. We have several that are stripped pretty clean. The next part, so once you get past the main breaker, you have the power distribution panel. And I'll show you the connector there. So that plugs into your battery and your circuit breaker. And then I'm missing the breaker between them, but that's okay. You get the point. So this is basically just a big power splitter, and it breaks it out into numerous channels, and you put the breakers in each channel that you actually want to use. There are some things that we have noticed, and I'm again curious to see whether you guys have had these issues. So these get covered up with a plastic plate, these two main lugs. They get covered with a plastic plate that those two screws go into, and then they get hidden. And what we actually had in an event was these vibrated loose, and you couldn't see that because the plastic plate was over it, and we actually lost the match because we died because we couldn't tell that that was loose. So one thing we've started doing is we provide strain relief. We always zip tie these main power cords to a frame of the robot, something very sturdy. And that way, because otherwise if you're yanking on this cord all the time to pull the battery out, you're constantly applying pressure to these, and that's going to make them come loose eventually. So we actually zip tie it right to the frame.
Yeah, we haven't run into that, but we do mostly have the safety of the red wire going to the breaker, which gives us some built-in strain relief there.
Yeah, 2017 up at Pine Tree, our very first match of the day. It was pretty sad to go out there and then not be able to drive or do anything that match. So we learned from that mistake. We won't do that one again. We'll make new mistakes. So
that was also the event where we ran aluminum wire by accident.
I'm getting to that. That's our other screw up. Wait for that. The other thing is, I'm sure you guys have seen it. Everybody who's had to plug into this has seen it, that these connectors are pretty finicky. They say use ferrules. We've actually had better luck with stripped, like 16 to 18 gauge twisted wire, twisting the braids together and pushing them in and getting the right depth of stripping on it. The ferrules we found are either they go in really easy or they never come out and then they break off inside. Those are pretty finicky. It's just something to keep in mind. But the bigger issue we run into is these two breakers. Have you ever had to replace your?
Yes, we have. River Rage, we ran into that.
So students should know that these breakers, to put them back, if you take them out, to put them back in requires more strength than you think it does. These little connectors don't seem like they're much. Yeah, but you should have to push on these to the point where you think this doesn't seem right, and then that's the right amount of pressure to apply to those. If you don't, they'll fall out, they'll get loose, and they cause problems. So these are non-resettable. So all these breakers, if they pop, will come back after a few seconds of cooling down. These two fuses are the only ones that are non-resettable. Obviously, they're fuses, so they don't reset. Once they burn out, they're done. And so if you're not getting power to any one of your channels, that's one of the first things you look at. But if you do end up replacing them, just remember, you really have to cram those babies in.
Yep. They're standard automotive 20 amp and 10 amp fuses. You can buy them at AutoZone.
Yep. Yeah, they're available everywhere. We carry a bunch with us at all times. It's pretty rare to pop these. We have done it, but it is pretty rare. But
we've only run into it when we were literally shorting the entire robot through our PDP.
Oh, these things happen.
Yeah, we have a destroyed PCM that was shorting out the robot. That happened. Another key one, if you are doing twisting into the ferrule slots, if you have a like loose strand somewhere, it can cause a short and instantly pop a breaker and pop a fuse.
Yep. When inserting that stranded wire, if you have one stray whisker, exactly, and it touches the other side, you're in for a bad time. So the next thing we're going to talk about is called the VRM, the voltage regulator module. Now, at first glance, it might seem a little weird. It's got 12 volts in, and then it's got 12 volts out. So what does this thing actually do? There's a couple things that this thing has inside. It's got what's called a buck boost. And if your voltage in is 12 volts and it drops because you're loading your motors down to, let's say it drops to 9 volts or 10 volts, this booster will actually boost this up to 12 volts. And that's important because some of the electronics on the robot, if they drop below 11 volts, they shut off. They take a little nap.
Radio.
Radio. Yeah. The radio is definitely one of the culprits. So this will keep the voltage steady even if your battery load is causing the battery voltage to drop significantly. So if you were to plug your radio or any of those sensitive electronics directly into a 12-volt channel on your PCM or your PDP, then as soon as it drops, your thing will shut off. And inspection shouldn't let you get through, but sometimes those inspectors don't pay much attention.
Hey now, just because I'm an inspector.
Or sometimes there are rookie inspectors and allowed out on their own.
Hey, the lights come on and it doesn't smoke. I'm guessing it's good. The other thing you'll see on this is this does have 5-volt connectors, and anywhere you might need 5 volts. This is really the best place to connect to that. We have used some external buck boosters for 5 volts, some DC-DC converters, and those are allowed. But really, this is the best one because it has support from FRC. You can find them from any team. If you go off the reservation and it breaks, then you're kind of hosed. So things like LEDs or 5-volt sensors, things like that, you can power off of this.
Yeah, the old cameras that had the 5-volt lug, that we ran it through that in 2019.
Yep. Yeah, they are very useful. Okay, I'm trying to think of our Ethernet switches, 5 volts or not. Look. So the next thing I'm going to talk about is the PCM, called the Pneumatics Control Module. And again, both of these devices, the VRM and the PCM, have these, they call them the ferrule connector type things. Same deal with the twisted wire. They're not great connectors. Once you get good at it, they're not too terrible, but they're nothing like the Wagos, the spring-loaded ones. Those are really nice. So these can definitely cause you some headaches. The nice thing about the PCM is the compressor plugs into it, the switch plugs into it. It's got a CAN ID, so you can talk to it over CAN and turn on solenoids on and off. The one thing to keep in mind with the PCM, solenoids that drive pneumatics are either 12 or 24 volts. This little jumper right here, if that's set to the wrong voltage, your solenoids won't fire. So I've seen plenty of times where everybody had everything perfect, it's all good, life is grand, it's wired, it's hosed, everything's plumbed properly, and it just won't turn on and off. And if you look at that jumper, it's in the wrong position. So there's a 12 volt and a 24 volt. So the one thing you've got to worry about that's about the only issue with these things is the jumper. Pretty straightforward otherwise.
Yeah, and you can't mix and match either, so that's something you have to take into account while you're building the robot.
Yep, and sometimes you need 2 PCMs, and that's not really that big of a deal, but it is something to keep in mind.
Have 112, 124 volt.
Okay, all right, so the next thing I'd like to talk about is speed controllers. And I've got a whole array of speed controllers because we've been collecting these for a while. You're not a speed controller, go away. So speed controllers come in a bunch of different sizes and shapes. They used to be pretty lousy back in the days of Jaguar and
Jaguars and Victors.
884s.
The Victors were amazing.
The
I don't know what you're talking about.
Oh yeah, amazing for making smoke. That's about it.
You could put more current through that. If you actually mounted them upside down and the fan failed, they would heat up so much that the solder would melt in the FETs and the FETs would fall out. I have seen that happen.
Yeah, that used to happen actually in BattleBots because BattleBots used to use those controllers. So the most recent one, or actually the oldest one, is this is a Talon. Are Talons? I don't even know if they're still legal.
Yeah.
I believe they are still legal. Original SRs are still legal. I'm not sure if like original Talons still are, but I know Talon SRs are.
Actually, so that's an original Talon right there, the OG, and it is not legal. But they're great for troubleshooting. They're great for demo bots, that kind of thing. So these are nice little speed controllers. These were one of the first ones that were pretty well sealed up. So there's nowhere for chips to get in. And that made a big difference. I mean, we always, every year, I don't know about you guys, we sacrificed a speed controller to the robot gods every year.
Oh, if you didn't blow up a speed controller, did you really play the FRC game that year?
You just write your events off. Don't even bother showing up. You're not going to win. You haven't done what it takes. So unfortunately, those are like $90 a piece back in the day. So it was not a cheap sacrifice to the gods. Actually, I'm going to do the Talon because there's a little bit of a story behind this. So this is the next version of the Talon called the Talon SRX. We use these pretty extensively because some of the alternatives hadn't been out yet. The Talon SRX is a speed controller. It allows you to control the speed of a motor and the direction. So you put power in, and you hook your motor to this connector, and then you hook it to your CAN bus, which is part of your control system wiring. And you can control this thing. You could say go fast, go slow. There's a bunch of other things. This is a very smart, very intelligent speed controller. It's top of the line. They're like $90 a piece, but they're great. This is like the gold standard, I would say. But they are very pricey. And Vex Robotics decided to make a knockoff. This is my understanding anyway. The Vex Pro, this is the...
Talon Victor SPX.
Victor SPX, yep. And it's only $50, and it has most of the functionality of a Talon SRX. It's just almost as good. The only thing it doesn't do is it doesn't measure current. But it has all the PID, the closed loop, all that stuff, and the packaging's about the same. It's actually a little bit smaller, but it is almost half the price. So in a situation where you don't need top of the line, the Victor SPX is good. These will also do following, so you can tell it to, if you have like a dual motor gearbox, you can have them both do the same thing. It's called following, so you can tell us to follow another speed controller, and it's compatible with all the other ones. So I'm not thrilled that they knocked off the SRX, but it is cheap and it's not a bad product.
My understanding is that they were clearly aware of how expensive the SRX was, and teams were not happy with it, and they wanted something to compete with probably the next controller you're going to talk about, the Spark.
Yep. Yeah, exactly. So that came out from Vex. Again, a good one. So the next one that came out was Spark. Now this thing is even cheaper. This is $40. It is probably the cheapest speed controller that's legal in FRC, and it's pretty lightweight. I mean, it's a kind of like entry-level thing. If you just need a motor to go and you're not concerned with any of the fancy stuff like PID loops or profiles or any of that jazz, Spark's not a bad product. It only does PWM control, which can make your wiring a little bit ugly and make it a little bit more difficult. But it does have limit switch inputs, and it is fully reversible. It's got a nice bright, really bright LED for status indication. It's got mechanical calibration, so you hold the pin down and you can calibrate the thing. It's a nice little speed controller for the price.
Yeah, there were a few years where we ran exclusively Sparks. Like, we weren't too deep into the nitty-gritty and all the, code end of it. So they did what we needed them to do, which is make the motors go.
Yep, and you can get twice as many or more than twice as many of these and burn them up or have a demo bot. If you've got a practice bot and you've got to build a whole second robot, I mean, you can't, it's like $1,000 in speed controllers generally on the robot. So
easy.
If you can save $500 and you don't need it, then these are a good option. And actually the battery tester that we're building right now, we're using Sparks to
I noticed that.
Turn on the load cells. So they also came out, and this is pretty recent. I actually just got this a few days ago. It was the Spark Max. This is their new Talon SRX. I'll do a little unboxing video.
Yeah, it's the Talon SRX competitor.
So the previous knockoff was a Vex Pro, and this is the Rev Robotics version of it. The the big difference with this one is this will also run brushless motors. So this will run the
Yes,
Neo
the
and the
Neo.
550, which is pretty slick. It does have the data port very much like the Talon. It's the same connector, everything there. And it has built-in encoder capabilities. It's basically a one-for-one for a Talon SRX, except this will also do brushless. And it's 75 instead of 90 bucks. So Talon SRXs are glorious, but right now they're looking pretty pricey for what you get. So
Yeah, you know, we're going to probably go into a different implementation of the SRX, but for the money, a Spark Max and a Neo is the best performance you're going to get for a $115 price point for a motor plus the speed controller.
right.
You know,
I
you
had
used to get that with the $90 SRX and a sim.
Yep. I did buy a 550 too. I've got that in the shop, but I haven't taken that out yet. So that's the last. I mean, we have other speed controllers, but these are really the ones we use. Any one of those four would be a good option for the team. The last one, which isn't a speed controller, but it is a motor, so I'll point it out. The thing about the Falcon, and I'm sure you guys have heard, is it's got a speed controller built right into the back of it. And so when you apply power to this motor, you just give it power and CAN bus, and everything's all integrated. So this is like a speed controller motor combo. We ran this last year for an event. We ran 8 of these, and they were amazing. They were really, really good. We had no issues. I always hesitate to adopt a new platform the first year it comes out. It's like buying a new model car. But we tried them out. We didn't buy any Neos. Did you guys buy Neos? Have you spent any
So
money?
we had 2 Neos on our shooter this year.
Okay. And they've been very well reviewed. They've been out for a couple years.
Yeah, we burned one up, but that's our own fault. Like, we look back at it, and we definitely were the cause of that burning up. That was our mechanical fault.
Sometimes sacrifices must be made.
Yep, exactly.
Can't make an omelet. So, the Falcon is a speed controller plus motor. It's basically a Talon SRX bolted to the back of a brushless motor. So
Yep.
we've been very happy
ran
with
for
this.
ourselves.
Performance has been good. It's got all the same libraries and stuff. So just another one.
We ran 4 of the Falcons ourselves, and once we figured them out, we had no problems from there on in.
So it's another option if they're selling them. We've been unable to buy them for a while. So
Well, we'll see with all the problems with trade from China.
it's going to be an interesting year.
Yes, it is.
They can't just call them up and say, hey, we need 10,000 of these and have them come in. So the next thing I'm going to talk about is vision. Should have been the strongest Avenger, but they nerfed him. So I don't have my limelights with me because our programmer actually has them, but we've used several different variations.
I think I can pull my limelight.
What's
I'll
that?
be right back. I'll pull our limelight. I'll be right back.
So we've used these in the past. Actually, I'll put them in chronological order. Actually, we've never really used the Pixie, but we bought it. Kind of a junky little camera. So this is a Pixie. It's good for color, but that's about it. It does some basic recognition. It's definitely not a full feature-rich vision processing system.
That's all we had in 2005.
Well, we've evolved. The next step up is an Axis, and this is an Axis IP cam. It's Ethernet and power, and that's basically all you have to do. You give it an address, and we used these a lot from like 2010 to 2017-ish, 2016-ish. You used to do all your vision processing on your controller. So like the Robo Rio would do all the vision, and they don't really recommend that as much anymore. I mean, you can still do it, but it's not where it's at. So we haven't used these in a while. They are pretty nice cameras though. They actually said to start using the Microsoft LifeCam or any USB webcam. We've got a ring light attached to this one. And you basically just plug this USB right in your controller and you can display it. You got somebody waiting in the waiting room too, by the way. You can display it and you can process it with either a Pi or you can process it with, I think a Jetson Nano people have used, or you can process it right on the Robo Rio. So you can take the feed from the camera and you can use vision processing. You can use Grip or OpenCV or the processing image of your choice and basically use targeting, tracking, all that jazz with any camera you like. There is a really, really, really fancy type of camera called the Limelight, which Jacob's going to bring on over and show us. And that is an integrated unit. So that has the processor built into the camera. So it's not just a camera, it's the camera and the processing system all in one, and it's a very high-speed camera. That's the one right there. That's a Limelight 2 or a 2 Plus. Oh, you're muted.
2 Plus, I believe.
Plus. So it's pretty pricey. It's an investment for sure.
$400.
Yep. But it is one of those things. I mean, you can spend your entire off season building a vision system, or you can get this thing and get it on your robot and start doing all the other things you want to integrate with your robot. FRC is all about choices. It's all about where you want to spend your time. Like we're spending time on a battery tester right now because we can. We've got some swerve projects we're working on because that's something we're working on. We could be spending all our time building vision. Nothing wrong with that. If you have students that want to do it, it's great. But when the season starts, there's no time for, hey, let's figure out Javoice and a camera. So you got to make do. And the Limelight is the slickest, best vision I've seen anywhere. I don't know
Yeah, it's almost a drop-in solution. Like you have to be able to use the code or use the output that it gives you, but it's basically a drop-in solution.
Slide the slider bars and you're doing vision processing. So that's a good way to save not money, but definitely time. All right,
You're trading time for money there. That is 100% the truth.
Yep. All right. So the next thing is my favorite. I'm sure it's your favorite too.
See, I'm an IT guy and network guy as my trade and stock and trade. So I know how finicky routers and radios get.
Yep.
That's what Dan and I are both IT guys, so it drives us nuts how terrible the ones on the robot are.
Yeah, it's pretty frustrating. So I would say, most of the control system components we've talked about are pretty rock solid. I mean, we have some things here and there. There's some connectors or things like that. But in general, it's a pretty good setup. However, let's move on to radios. These things are garbage. There's really no other way about it. These are open mesh, either AN or AC radios. They are not really meant for doing what we're doing to them, like most of the other things. But here they are doing FRC stuff, and we have had significant problems, usually in playoffs, usually when we need them the most, have them bite it.
Mm-hmm.
So why don't we give me the close-up, because I'm going to show them the thing. Now, there's a couple things that can go wrong with these, and I don't know if you guys have done this, but first off is it only has 2 ports. So if you want to put 3 or 4 network devices on there, well, now you have to put a switch, and we use these little guys. They're definitely not high-end switches, but they're not. They're little 5-porters. The only thing to keep in mind is if you are going to use a little switch with your radio, always plug the radio into the Robo-Rio. Do not plug the switch to the radio to the Robo-Rio, because if this dies, and it can and does, if your radio is going through your Rio, through the switch, your match is over. You're all done. So direct to the Rio with this, and then put your accessories, because if you lose vision, it's not great, but it's not the end of the world. So, and this little switch, we put power poles on just about everything, including this and the wall wart, so it's always easy to pilot. This
is a lesson in points of failure.
Yep.
There only be 2 points of failure: the place where you plug it into the radio and the place you plug it into the Rio.
Yep. And as I'm sure you're going to get into, and I'm going to get into here, is power. So power is a serious issue on this. This barrel jack is not a good fit with the barrel plug they give you.
Trash.
It's trash. Teams are always like, oh, it's no big deal as long as you hot glue it on. And that's, kind of the definition of garbage. So we don't use the barrel, and I doubt anybody really does unless they're crazy. We use this. This is a power injector cable. It's provided to you by First. This takes these 2 little leads, puts 12 volts into the Ethernet jack, Cat 5 jack, and then you plug in your radio, and now your radio has power. And then this side would go to a patched cord that goes to wherever you want it to go. So never, ever, ever use a radio without using a PoE injector. Never use the barrel jack. It's just junk. So that's just a thing to know. The other thing we found, and this is actually a documented thing, is that there's a little flap of metal on the inside of this radio. And that little flap of metal, if you bump it, it will short against the circuit board and reboot the radio, and you lose 45 seconds of a match. And we had this happen. There is, why don't you bring up go to radio issues. There are many on the training guide thing.
Oh, you got them in your slide.
I got them in my slide deck. So there is actually a FRC supported fix for this. So there is a document. The instructions are provided here. So this brings you to WPI lib documentation, where you can look up this modification, and what you do is you open it up and you insert a little piece of electrical tape between the metal flap and the circuit board, and that'll prevent failures. And so there you go, look at that. And so we've done this with all of our radios. Pretty slick. And we'll have these instructions available in case. Have you guys done this by chance, Jacob?
I actually haven't looked into that. I didn't know this existed. So
my electrician that just graduated found this out. Why don't you give me the close-up video again? And what you'll see on the back of any radio that we have had for a while, you'll see modified, although poor Kale can't spell. Modified means he has taken it and he's done that little hack to it. So all of our radios, he was very good about modifying them. And what we do has been our general practice of the past few events is we bring 2 radios to the booth at the beginning of the event, and we program them both.
Yep.
And that way, if we have any radio issues, we just swap the other one out. And then I'm going to tell you the last secret that we do, and we've done this for quite some time now, and we've never had a problem since we started doing this. We build a radio coffin. So this is our radio coffin, and it's got room for ventilation and for the lights to peek through. And it's basically just a foam thing, and we stick the thing in there, we zip tie it and tape it closed, and then it's kind of hard to see, but if it gets bumped or knocked around, it doesn't take any damage. So our little radio coffin has been invaluable over the past few years. We have several of these, and we just zip tie them and then stick it right on the robot, and then issue solved.
So I have a little power secret about the radio that is a tip that not a lot of people know. It makes sense to do it this way, but it's something you can screw up. The power over Ethernet needs to go into the left port, the one next to the barrel jack.
Yes. Yes. The ports on the radio are not, you can't do whatever you want with them. They have to be specific. So if you try to program with the wrong port, it'll fail. So the 2 ports are not basically do whatever you want with them. They are specific. So you get the power one, you have to program with one. I believe even your Rio has to go into a specific one.
Yeah, the Rio has to go in the first port, which is powered over PoE.
Which I don't know why the switch is like that, but that's cool.
They need to make their new Rio inject the power, but I don't see that happening.
Yeah.
Or just build the radio into the Rio and call it a day.
Give me an SMA connector, I can put an antenna on it.
There you go. So I'm going to talk about wire real quick. In the documentation, the schematic, they showed the thickness of wire that's required. You got that up there. And we have switched from Zipcord, which we've been buying from PowerWorks and other places. A local area has been giving us some real good discounts on it. But we switched to a silicone and really soft, supple welding wire. And we've seen it's made a significant difference. In 2017, we had an elevator with a bunch of zipcord on it. And we were seeing a 2-volt drop across it. It turned out that it was copper-coated tin.
Coated aluminum.
Coated aluminum. It was junk. And we actually had to run to the hardware store mid-event.
I bought extension cords like the SOOJ cord, and it actually worked after that. It was an 18-foot run of wire from the bottom of the elevator to the top. And at the top of it, we were measuring 6 volts going into the Talon, and the Talon was resetting.
Wow.
So wire can make a huge difference. Now, I mean, generally, you're not going to have an 18-foot run on a 30-inch robot, but if you do have a long run and you've got crap wire, it makes you think, even if you're doing a 6-foot run, and you're using crap wire, you're still losing 20% of your power. And so that's something that you got to just be aware of and buy the good wire. We actually get this from an automotive place who helps us. They sponsor us downtown, and they give us really beautiful all copper
that's beautiful.
welding cable.
That's actually battery like starter cable straight from the Napa store. And that's what we use for our batteries. And that's 4 gauge. It works really well. The stuff we use for everything else is it's a silicone ultra flexible wire that we found it on Amazon first, but I ended up buying 150-foot rolls of it right from the manufacturer. And we run 10 gauge almost exclusively to all of our.
Yeah, we primarily switched to 10 gauge wherever, we were running, robot power to motors or to anything else that,
It fits all the
really needs the 40 amp.
Yep. Yeah, there's no reason not to. I mean, why would you? You're not saving much money. And we, at this point, are almost entirely power pole. I know some teams have switched over to the RC power connectors, some of those more unique setups. But we've done power poles for a long time. We bought the nice crimper and everything. And have you guys done all power poles? Have you done a lot of them?
So this season was the first season we went to power poles. We had mixed results, but also that was partially because we were so new to it. I'm still debating it with one of my electrical guys, but we'll see. We'll see.
Do you guys have the real crimper?
Yes, we do.
Okay, because we did that without the real crimper for a couple of years, and that was awful.
Yeah. It does take a little bit of practice, but we use it for everything now. The nice thing about the power poles is you can build wiring harnesses, and you can key them. So I can turn these 90 degrees, and then what we do is we build harnesses where this can't plug in anywhere else but correctly. So no more burning up speed controllers, no more plugging in the wrong thing and having problems. We buy all the colors. So we color code. Now, they don't let you color code your positive and ground, but you can definitely color code your motor wires. You can color code any of your data cables. We've even gone so far, which it seems overkill, but we power pole our...
I was considering that because that's just a huge upgrade.
So the secret to that is... Give me a zoom close up.
The only thing you got to remember with the can is it takes up a lot of space. So if you build the control panels where you got all your channels next to each other, you got to plan for the room to fit all those power poles next to each other too.
Yeah.
So that's the only drawback of power poles and the CAN bus wires.
So we crimp a ferrule onto the small gauge wire, and then we crimp the power pole, and it works like magic. It's perfect. It works like $1,000,000. The nice thing about it, though, is you can add your CAN bus directly to your wiring harness. And that, when you want to plug something in, it's just a matter of plugging the harness in, and then you've got your data bus, you've got your power, and we haven't had any problems with interference or induction or anything like that.
I've only seen induction problems when you literally run it right over the motor.
Right. Go fast. Hey, it's acting weird. I wonder why. So, and then you guys, I'm sure, use the big power poles. I have seen grasshoppers bump to the next size up of SB connector. That seems crazy, but
they still have to use the SB50 in the middle.
Yeah.
So I don't know why they're bothering. It seems so weird.
It does. And they're smart guys, so I just find it unusual.
You can stuff a 4 gauge into the SB50. It's not a big deal.
Right. Orange Chaos 4564, they have a 3D printed tool that bolts onto here, and it's a little crank lever, and what it does is it separates the two connectors so you don't have to like wrench on it. And I think we're going to try printing a few of those out. Basically, it's just a little cam, and you spin the cam, and it automatically checks it.
Send that my way, or I'll go beat up Brent for it.
Yep, I think last Battle of the Bay, we ran into him. And is he the young guy?
He was, I believe, their human player last year, and their human player in 2018.
Okay. Yeah, so, I mean, I saw that, and I'm like, Orange Chaos is full of smart guys. They have all sorts of cool stuff going on. So, yep, we swear by PowerWorks. I have seen some teams, and I haven't really gotten on board the JST train, but for data connections, a lot of teams are switching to JST 3 or 4 pin, or a lot of teams use the PWM. I hate using PWM cable for anything, really.
So PWM has gotten a little more reliable recently because of Vex introducing the cable clips, but even then, it's still brutal.
Yeah, it seems so easy to get caught up. And We are considering a JST crimper. We'll let you know
I
if
have
we do
one.
that.
How about one?
Did you?
Yeah,
And
I
then
got the whole kit.
we'll see if we can build our own cable, see how that goes. I mean, these are pretty tiny connectors, so, but at least they lock, and at least they're multi-pin, so that's cool.
Yeah, that's true.
You know, it's just one of those things. So data cabling is kind of a problem still. There's no like power cabling, power poles. I consider that problem solved. I don't have an answer for this yet.
We've tried RJ45 connectors and have had mixed results with those.
You got 2 people in the waiting room.
I just joined. It's been hit or miss getting a connector that actually fits and works reliably. We've had a few issues with. I'm lobbying this year for like DB connectors because they're screwable and they're solderable, and we'll see how well that goes. So Dan's probably not going to like me, but you can fit a lot of pins in the spot of a DB25. So.
Well, it'll feel like we're back in the 90s. It'll be fine. So the next part is the Robo Rio. And you guys, I'm sure, have plenty of experience with this. They are doing a new one, I guess, in 2022, a
Rev
new
2
version.
coming out starting this year, I believe.
So we'll see how that goes. It's not supposed to be a major upgrade. It's just supposed to be like a revamp. A new
Internals
version.
mostly, from what I read.
Yep, more RAM and that kind of jazz. So let me click through and see what we've found. So I don't know if you want me to go through the inputs or not. Are students interested in hearing about what connects to what? Or
No, I think we're pretty good there.
okay, yeah. I mean, I don't want to go over the basics. Just over things that I think each team may have found in the past that were kind of secretive. So one thing you'll see is we tape over all the connectors or any area where chips can get in. They do make 3D printable clips to hold connectors in. We haven't really ever needed those, but they are available. And
Yeah, now that most teams are doing CAN sensors and CAN motors, you don't really need the clips on that unless you're doing relays.
yeah, we're past the dark days of 8 PWM cables coming out of it and 15 PWM cables coming out of the whole stack, and then that. We have had a time though where a metal chip, an aluminum chip, did get inside.
Mm-hmm.
And the only way we found out was our indicator light, as soon as we turned on, would stay red, our status light, and we could not get the thing to boot. And
Yep.
It took a little bit of searching around, but they said, open it up. So we popped the cover off, and sure enough, tiny aluminum chips shorted between ground and
Mm-hmm. That happened to us as well. We quote unquote killed the Rio, and then we brought it home, vacuumed it out, brushed it off, and it was fine.
I am amazed that you can short ground to 5 volts, and as long as you clear it, it goes, I'm good now. So
there's protection circuitry in there. That's what the little red light means, is it's browning out.
I'm just impressed. So not too many people go through that level of effort. So that kind of says some good things about NI. But yeah, I mean, if you ever have that situation where you've got a red light, if your robot brain is stuck on red status, one of the first things you can do is open it, clear it out, do a really good job of getting it cleaned out. Check all your connectors in here. I have seen little pieces of aluminum fall into between the pins there. Give it a good shake out, and then usually they come right back to life. So what's the other issue? I think that's the only issue we've ever had that was major with the Rio. Have you guys used much the MXP port?
The MXP, we've only used it for the what's the name?
The NavX?
Yeah, we've only used it for the NavX.
Okay. Yeah, we haven't done a ton of stuff. We did get some extra supplies this year. So Rev does make a display that provides additional I/O, and it's also got a couple knobs and switches that are all programmable, and you can put anything you want on this crystal display, which are the 8-segment display, which is pretty cool. So we haven't had a chance to play with this too much, but I forget where we ended up getting it. It was on sale or something, so I picked it up. And then they also do sell a breadboard, prototyping board, that you can plug into it and then do your own development on it. But we haven't gone for that too much either.
Yeah, we haven't touched that at all.
Yeah, so the other thing we found, this is an Arduino shield that plugs into the MXP board. So you can take it's basically the Arduino pinout, and you can slap it on there, and then you can actually put an Arduino on your Rio, which sounds kind of dumb, but we've used that in the past to do some real-time OS stuff where we needed, like driving LEDs or doing tasks that we don't want to busy the Robo Rio up with. I know it's got an FPGA, but there are times when you want to do something, but you don't want to kill the CPU on your controller.
You mean control LEDs?
Exactly.
I mean, the other thing too is like in the past we've actually done robot status LEDs where we tell our driver what the status of the robot is with driven LEDs.
Yeah, we use the addressable LEDs and have them flash different colors or do different patterns depending on robot feedback and status, and does the intake have a ball in it, that kind of stuff.
Sometimes I think it's hard for other teams to see that our lights aren't just for show. A lot of the times our LEDs are doing something to give us information. We found that when you're driving, you definitely get that tunnel vision where you stop looking at the drive station and things like voltage, things like time left. You know how it goes. You're in the zone and your brain's not going, your driver's working, and they completely forget what's going on the field. And having your robot blink bright red when there's 30 seconds left is an immediate like, oh, I need to go climb kind of thing. That's something we've used in the past. It's pretty effective.
Yeah, we've done similar stuff in the past too, and I've wanted to do it again, but we never had time.
Have you guys? Last year we did the Robo Rio, where it drives the LEDs directly. Have you had a chance to work with that?
No, but in the past we actually ran ours off of relays to do the status change. We had RGB LEDs that were hooked up to 3 different relays to get the RGB.
Oh, that's clever. They did release a new library last year. I think it was the first time they released it, where you can PWM or you can use addressable.
The addressable.
You can use addressable LEDs directly off your Rio now. So something to keep in mind. It makes it a lot easier. You just pull your line for addressing, and then the 5 volts. That's where we pulled out our handy, trusty USB battery and gave it 5 volts off of that, and then the data came from the Rio, and it was really slick and easy. Piece of cake.
I'll have to look into that.
The 2 years ago, we did an Arduino with I2C to the Robo Rio, and that was a bigger time commitment than we probably should have spent making LEDs work.
Yeah, the I2C port's finicky.
The libraries aren't quite there yet. I mean, they work, but boy, takes commitment. And so you guys do use the Cowie Labs NavX. You guys have used that in the past. And do you have the big one or you have the little one?
You have the little one.
Little one. Now, have you ever had to do the vertical versus horizontal calibration on them?
I believe we did 1 year, but it wasn't a huge issue. We had to remember. We just remembered to do it once, and it was fine the whole season because we kept it vertical the whole season.
Yep, our very well documenting electrician last year was really good about labeling it what calibration it was, so we don't stumble over it in the future. But that is something that some teams don't realize, that you have to calibrate it for the.
Yeah, realistically, you should recalibrate it anytime you move it.
Yeah, and they need firmware updates every so often anyway, so it's good to just redo the whole thing. And then we've always tried to keep ours in the center. We found if you keep it in the center of the turning point of the robot, it's way more accurate. If your robot turns and your turning wheels are here and your robot Rio is way back here, we found that does affect the sensitivity of the NavX. So that's something.
I mean, that makes sense. Definitely makes sense.
All right. So I talked to them last year, the vendors, and they were saying that they're getting good enough soon where they think you'll be able to do the calculus to integrate your acceleration curve and actually get your velocity and position straight from that.
Oh, so like on board, just pull it right from their library?
Yep. Their acceleration curve should be accurate enough that if you do the calculus and you integrate twice, you should be able to get to the position, and it should be pretty close to accurate. So that's something I'm looking forward to.
We shall see, because then we can have potentially the era of fully autonomous FRC robots.
Yep, actually knowing where you are in the field, within the nearest inch or two would really change the game. All right, I think we're on time. We're just about there. You guys, you've always used the Maxbotic stuff. Have you ever done the ultrasonic Maxbotic
We
stuff?
have not used that ultrasonic. Every year it comes out of the kit of parts and goes right into the
special bin?
Control system. Yep.
We have used these pretty successfully. These are sharp IR sensors. They don't work well against polycarb, but they're cheap and they plug right into an analog port, and they are stupid simple to set up. They come in a bunch of different distances, so you can say 0 to 3 feet, 0 to 6 feet. But if you're just looking for a simple, dumb distance sensor that's not going against polycarb, these things are the ticket. And again, they're dirt cheap.
So the driver station wall.
Yeah. If you're usually what we're doing is in autonomous is we're going up against an element. It's not clear polycarb. I should be more specific. If it's clear polycarb, it doesn't work well. If it's got paint on it, it seems to work okay.
If it's reflective, you're good. If it sees through it, then it doesn't work. So the aluminum wall. Yeah.
And we have used this. I wish Cal had joined the meeting because he's been our electrician for a couple of years. We now have our new electrician, Amelia. I don't know if Amelia, are you here? Yeah, you're here.
Yeah.
Have you had any experience with the ultrasonics yet?
I think we worked with it a little bit last year just to figure out what we wanted to use.
That's something that I don't think we spent a ton of time getting good at them, but you know.
No, we didn't.
So, and then I'm going to pull these out of the old.
Oh man, this is a blast from the past.
Are there new relays now?
I don't believe they have released new relays. I believe the spikes are still the only FRC legal relays.
There is a automation direct part that is valid for FRC use.
Right.
But it's like $60 and it's kind of garbage, just like the spike.
Is it reversible like the spike though?
I don't think so. I think they're single. They're not an H bridge.
Yep. Interesting. So, I mean, we haven't used the relay in forever because, I mean, for $40, you just, you do that.
Yeah.
I don't understand, but.
The only time you use a relay is when you want max voltage or no voltage and nothing in between.
Right. And so that has not come up in a long time. Back in the dark days of, we had snowblower motors and window motors and things like that. We did certain things with them that required that.
Windshield wiper motors, I think we had legal one year.
Oh, so good.
I love those.
So good. And then we still got these big old limit switches we haven't used in a while. And I wish I could find where to get more of these. But the only place I find them, they're very expensive. So
yeah, like I think in the past they were donated by a company who just happened to have a bunch of them lying around because they used them in their machinery on the shop floor. And that was it.
So we're always looking for these, but nobody seems to carry those anymore at any reasonable price. And the last thing we've done is I've started testing out some of these IR pass-through sensors, which is basically just an emitter and a receiver. But I think we need to build some drive circuitry to handle that. So that's something we've been playing with, but I haven't really gotten far. I've been working mostly on the battery tester, and then we have started a swerve project. Our programmer right now is trying to get that sorted out, but
I wish you the best of luck.
It's challenging.
Yeah,
no doubt about that.
It's arguably one of the toughest drive systems to make, and you've already made Mechanism.